Um. Well, it. Well, when I put on my answer that it goes down to the area where your body fat is.
Okay. Yeah, I see that. That's good. All right, so I have some other people saying that it's destroyed. It moves somewhere else. It turns into muscle or loose skin is a good one. You lose fat, so you are less heavy. That's good. It just moves somewhere. It turns to sweat. It's destroyed. Destroyed is a common answer here. All right, where you guys said it was destroyed, and that's fine. All right, so we're gonna learn about something called the law of conservation today, and it's gonna help us understand where this stuff goes. Okay, but first we're gonna do. You're gonna see a quick demo of vinegar and baking soda. Good old vinegar and baking soda. So um, in this next slide, I'm going to measure these things out, and I'm going to show you what they weigh, and that's going to be before we do the chemical reaction together. So I'm hoping that everybody here has done the vinegar baking soda thing. So it's not going to be a surprise what happens, but I do want to show you something that you probably haven't done before, where you measure the mass of these things before and during and after the reaction. All right. So keep an eye on the masses. So first up on this scale, I have a cylinder of vinegar. So that's white regular vinegar you'd buy from the store right there. And it weighs 23.8 grams. So the weight is 23.8 grams of just the vinegar. All right, so this contraption here is a special flask that has a little nozzle at the top that allows you to capture gases that escape from the reaction. So I have a cork on top and the balloon on the side to capture the gas that's produced. So if you guys have ever seen this reaction, you know it gets bubbly. All right, so I'll be capturing the gas on the side there. This beaker or vial weighs 77.7 grams. So I want you guys to think about that and channel your inner, what is it, second grade math skills and add these things up. So add these together and show your work. So what should the total mass of the reaction be? What is the total mass of the reaction? So draw it out. Oops, that is ugly. So plus, add them together and then give me the answer right there.
Oh, I didn't know we could draw on it.
Yeah, so you can draw with your finger.
Okay.
All right, for those of you guys who just got in here, here's the code. Hop on and join us on the nearpod. All right, so far I like what I see. Everyone is right. Um, Matthew, check your work. You have it set up correctly, but check your math real quick. So you can go ahead and write on the screen. Let's see if my stylus works right now. Plus 77.7. So that's what it should look like, something like that. All right, Matthew, good fix. All right, Isaiah, good job. All right, if you have submitted it so far, everyone's got it right. Good work. Come on, people, get with it. All right, so here's what I'm looking for. Go ahead and share it. All right, 23.8 plus 77.7 is 101.5. So 101.5 grams. So together, before we do any chemistry, these things weigh 101.5 grams. And that's what we're looking for. All right, so um, I got a video of this being mixed together, but before that happens, all right, what will happen to the total mass of this reaction once we combine everything? So once I dump the vinegar in the baking soda, what's going to happen? And that's what I'm looking for. All right, so you got three options. You have a minute to answer. This is a good indicator of who is actually here and paying attention and who's going to be getting points today. So if you can't answer one of these three in a minute, then I know you're not paying attention.
Can you see me now?
Yep,
All
good
right.
job. Whatever you did worked.
You purple.
All right, Jimmy, make sure you pick an answer. Beyonce, are
Pick
you
the
awake?
answer.
I did give you an answer.
Okay. All right, I see it now.
See mine?
All right. All right. So here's what we got. We got 65% of us say the mass will increase. 25%, 23% say the mass will stay the same, and 6% of us say the mass will decrease. So overall, pretty good. All right. So the vast majority of us say that the mass is going to increase. All right. Now think about it. Why did you say that? All right. And that's what's next. Why did we say that? Don't worry about being right or wrong. What in your brain led you to say that? So what in your brain led you to say that? Type it out.
Okay.
I only got one reason.
All right. What is that? Type it out.
All right, man. Always want to
All right. Tamara, I like your answer. Keisha, I like your answer too. All right. Hunitha, good job. Lanisa, good job. All right. Matthew, yours is a little bit vague. All right. DJ, not bad either. All right. At least you guys are providing evidence of what you said. So, Jimmy, erase that right now. I don't know is never a good answer. So, do you think it's going to increase, decrease, or stay the same? And why do you think that? Will it increase, decrease, or stay the same? And just give me a random guess as to why. All right? Why is it going to do that? Just give me something. DJ, what's up?
My computer went dead. I had to join on my phone, so I'm gonna be right back.
All right.
Hold on, there
Is-
am I. It just turned on. From the join back.
Kevin, can I have more than one word, please? Come on, man. You're smarter than that. It's okay to be wrong. I just need to try. Jimmy, I need a new answer.
Hey, Miss Hustle.
She's muted, or or she's doing something.
Jimmy, your answer doesn't make sense, man.
Duh.
Jimmy, when you mix two things together, what's going to happen to the mass? Is it going to increase, decrease, stay the same, and why? Like, I'm not asking you guys to like go like super scientific on me. I'm just like saying, just think about it. So like, here, Tamara, you had a great answer. Look, this is really simple, right? Because when you add two things together, it rises, and that means it increases. That's pretty obvious, and it makes sense,
Yeah,
right?
good.
So anything like that. All right. Let's see. All right. When there's a chemical reaction, it causes the mass to get heavier because new substance is being formed. That's great logic. You're gonna make something new, so it's probably gonna weigh more than it did before. All right. So that's what I'm looking for. All right. So I don't like. I'm trying to get you guys to be comfortable in making guesses based on your observations. So please just try. Don't give me I don't knows. Don't give me I just guessed. Even when you guess, you're deep down inside, you're making a prediction or something based on something. All right, so there's something there. All right, so hopefully this works on your device. I'm gonna play it on mine. I'll play it on mine. All right, so if you want to play it on your computer, you can too. But if you want to just watch my screen, I'll play it as well. All right, so you got the vinegar here. And in the last picture, you saw the setup. So here's the math we did. 77.7 plus 23.8 is 101.5, just like you guys said, because you guys are good at math. All right, so I'm going to do a quick mix. All right. You can see the balloon expanding. All right. Make sure you're paying attention to the mass. Look at the mass. All right, I'm going to rewind it a little bit. All right, because on the next slide, I'm going to ask you what happened. Quick mix. This is the before, and this is the after. All right, so what happened? That's basically what I'm asking you. What happened? What did you see happen? Talk about what it looked like, what it sounded like, what changed about what was the before the reaction and what after the reaction. What did you notice? What happened?
Good job, Mr. P.
Thanks. Typing's hard. I'm not a good speller either.
It's okay.
All right. All right, DJ, good job. All right, Matthew, good job. Lanisa, good job. Keisha, good job. Unitha, good job. All right, so I'm looking for stuff from Jimmy, Tanila, Tatiana, Keisha,
Me.
Kevin. So come on. There we go. All right, got it. Beyonce, let's go get something in there.
I'm still writing.
All right. Myra, what's going on? You got something?
That's all I got.
All
Yep.
right. Really? It took you that long to write that? Get out of here.
Because
All right. So let's see. Here's some good answers. All right. The balloon got a little bigger and the liquid went up. Let's see. Here's a good one. It sounded like it was sizzling at first, but the bottle let it drop all the way down. The balloon started expanding. Good. let's see here. Once the chemicals mixed, the weight got heavier and then caused the balloon to blow up, started to fizz and buzz. All right, and then it got clear as it finished buzzing. All right, good. So here's one thing I want to really focus on is that the mass, I'm going to fast forward here, didn't change. So even as this chemical reaction is happening, you see the mass from the second once I put it on and we get the weight, there's that 101.5 that we calculated. And then once the fizzing chemical reaction stops, it's still 101.5. So the mass is exactly the same as what we calculated it to be. And this is called the law of conservation of mass. If you ever heard of the word conservation, you might have heard the word conservative on TV before. All that means is that it's something that prevents the use of a wasteful resource. All right, so that means it keeps things around and it's not wasted. So that's a really good way to think about it is mass is not wasted, it's always converted. So matter or mass cannot be created, like appear out of nowhere, or be destroyed, just vanish into nothing. So the law of conservation says that when you do a chemical reaction, the weight of the objects you started the reaction with will be the same as you end it with. Now, this is a little bit tricky because when you do chemical reactions like burning something, if you burn a piece of paper, you're doing chemistry, you're doing a chemical reaction. However, that piece of paper is going to weigh, the ash weighs a lot less than the paper did before you burned it. But you lost the majority of your mass in the smoke of it being burned, which in this chemical reaction is why I put a balloon on it so that it could capture it and still stay on the scale physically. So that way we wouldn't lose any mass while the chemical reaction is happening. And that is a key component of chemistry, is that matter cannot be created and it cannot be destroyed. All right, we cannot play God and just make things poof appear out of nowhere or boom disappear. So that's called the law of conservation of mass. And this is a crucial law in chemistry and physics too. You cannot just create or destroy things. So with that in mind, we're going to learn about where our fat goes. So hopefully you guys can hear this too.
There are some things in life that when they're around, we wish they weren't there, and when they're gone, we're just glad they left. For many of us, one of those things is fat. But your fat tissue is full of important biological molecules called lipids, long, stringy compounds of hydrogen, carbon, and oxygen that are great at storing energy in their chemical bonds. When the molecules are broken apart, they release the energy stored in their bonds. We often refer to this process as burning fat. But when you burn fat, where does that material, the actual stuff that jiggles around and cushions you and insulates you, where does it go? Interestingly enough, a recent survey of doctors, dietitians, and physical trainers revealed that even the experts in fat loss didn't know the answer, although they thought they did. More than 50% of the respondents thought that when you burn fat, all that mass is simply converted into energy and lost as heat. It's a common misconception, but it's not possible. I mean, just because you don't like something doesn't mean that the laws of chemistry don't apply to it, and one of the basic principles of chemistry is the conservation of mass. This just means that the same amount of material always comes out of a reaction as goes into it. Even if that reaction happens to generate heat, you'll wind up with the same number of each kind of atom that you started with. So when you break up those lipids in your fat cells and release their energy, all of that hydrogen, carbon, and oxygen in those molecules will still be there afterward. But if you burn a lot of fat and it's not there anymore to hold your pants up or whatever, where did the mass go? Turns out, you exhaled it. Biologists at the University of New South Wales recently did an atom-by-atom breakdown of where the mass of your fat goes after it's burned in your body. They found that for every 10 kilograms of fat that you burn, you have to inhale 29 kilograms of oxygen to metabolize or break down the fat and release its energy. And the process of breaking down that much fat produces 28 kilograms of carbon dioxide and 11 kilograms of water. So for every kilo of fat that you burn in your body, more than 80% of that mass is lost as carbon dioxide that you breathe out. The other 20% 90% you lose is water, and your urine, your sweat, or depending on how hard you work out, your tears. But if you do the math, you'll see that all the mass in that fat-burning reaction has been conserved. 10 kilos of fat plus 29 kilos of oxygen equals 39 kilos total, and together they produce 28 kilos of CO2 plus 11 of water, which also equals 39 kilos. So remember that the next time you're huffing and sweating on a treadmill or walking your dog or really doing anything that makes your body call on its energy reserves. You're basically just emanating fat through your breath and your skin, but in a good way. Thanks for asking, and thanks especially to our subbable subscribers who keep these answers coming. If you have a quick question, let us know on Facebook, Twitter, Tumblr, or in the comments below.
It's 2:20.
I see that. I just wanted the video to finish. All right, so you actually exhale it. So you actually breathe out your fat. You don't. It doesn't turn into water. And if you put yourself in a giant bag, you would see that too. All right. So before you go, all right, Beyonce is going to miss this and get a 0. All right. There's an exit ticket, and it's like 4 questions long. It's really simple. So you're going to go here. And it's also located where it says Law of Conservation Nearpod, which we did, and exit ticket. So if you missed anything on the Nearpod, I'm going to post this here. And then here is the link to the exit ticket. And then by the end of today, I'll have a video up of our class. So you can go there and you can check it out and rewatch this video if you need any help.